Hello, class, and welcome to our MET400 senior project. We titled it Easy EV. I'm joined today by project lead Jason Zink. My name is Andrew Ouchi, as well as Dustin Lockhart, and I'm going to be going over a few of the slides that we're going to be presenting today. First slide is going to be an outline of what we're going to talk about throughout this presentation. We have an introduction, description of the projects, the market research, how to use it and how it works, the block diagram, schematics, flowchart, a parts list, conclusion, and references. First up is going to be introducing EV. Introducing EV is all about motorizing a wheelchair that doesn't have a motor on top of it. So right here is a schematic of what we planned on doing for our initial projects. So the project is going to include building up a wheelchair with motors, a battery, as well as a controller. We're going to use some awesome controllers. What is this? I don't remember.
That was the joystick, the battery that was supposed to hang off the back, and
Got
the
it.
original drive wheels and everything.
Got it. Thank you for that, Dustin. And then some market research, why we want to do this project. Well, in America, we don't see as much of a need for it because Americans, well, we kind of have a lot of money. We're kind of a first world country. So we're actually going to be targeting our second and third world countries because they're the people that could benefit from this the most. Traditional electric wheelchairs in America can cost anywhere from $2,000 on the very, very cheap ends, all the way up to $6,000 or $7,000 on the more expensive end. Our goal is to get this wheelchair to a price tag of under $500. This could be a potential very large market opportunity because the wheelchair industry is a $1.2 billion industry of manual wheelchairs that are sold worldwide. So I'm going to pass it off on to Jason, and he's going to describe a little bit of how this works.
Okay, hello class. So this is the system here. It's basically broken down into like electronic and mechanical portion. And what was mentioned before was the battery pack on the back, the joystick, and then the two motors operating. The point of the project was try to create a module that could be simply attached to any wheelchair to just have it go from manual to power. And then I think that's it for that slide. The block diagram here. So this is going into the electronics. So how we initially set it up is we're using the Arduino board as a microcontroller. So it'll take the inputs from the joystick analog, convert that into a digital output to the motor controller. And then the controller would then adjust the power from the battery, the 24-volt battery bank, to the DC motors. And then we're using the same power from the battery bank to control the Arduino board. And that will be shown in the next slide here. I'm sorry, this is the flow chart. So this is originally how we set up the joystick output. We had to figure out which way the motors were kind of oriented so that when it would spin, it would actually go forward and backwards. And as you can see here, it's just a basic breakdown of that. Next slide. This is the original setup of the wire connections. So as you can see on the bottom is the joystick, the analog inputs going into the Arduino board, and then the digital output to the Sabertooth controller. And then that is then going to the motors for the right hand and left hand. We originally were going to put a speed controller in the middle, but I believe that's just going to be future work now. And then now we're going to go into the schematics. So this will break down our part list and all of the mechanical parts we're putting together. So you can see on the left-hand side is the full assembly on the wheelchair, and the right-hand side is an exploded view of the assembly. This is still kind of basic how we had it set up, kind of the quickest and cheapest way we could put it together. And you can see how everything's going to be mounted. Go to the next slide. So this is the weldments that were going to be attached to the rail system so we get the full adjustment. And we use two of them side by side to get a little bit more, I guess, moment arm while the motors are against the wheels. Next slide. We got these side by side. So this is, yep, just more of the dimensions here to get the full adjustment. And then we had two options on the wheel. One was a 3D print based on a timing belt pulley wheel that kind of fit the tire size. And there were some issues there, but that was the cheap route. And then we, our other option was creating a fabricated aluminum wheel that we'd have to mill, but that was going to be too costly at the time. So we kind of just ran out of room on that one. So that might just be future work at this point. That I think that includes the schematics. And then the last slide here is just showing the full range of adjustment. So when we place it on any type of wheelchair, we expect that this can be adjusted to it and completely modular. And the parts list, that was, there's some more of the electronics part list, and then we kind of went through all the mechanical aspect there. And now I will hand it off to Dustin to talk about the testing and analysis part, and we'll keep it going.
This right here is a small video. Yeah, Christ, yeah, that's me. So, recently retired. That's why I'm growing the beard. Anyways, as you'll see in the video, it does work. It does function. And I know it looks rudimentary, but functionality is key.
Yep, we're able to get it all mounted. Wheels are turning. That's what we wanted. You could probably go to the next slide. All right, I think you're just talking more about the issues we were seeing here. Oh, does it actually?
I think this is the one he's gonna move them.
Okay.
Yeah.
Oh no!
So the reason I found out later why it was turning to the right is that right motor was actually starting to eat away at the 3D printed wheel. So it wasn't getting the full grip that it needed in order to actually work. And you'll see in this small video, it loses, but it still has enough power to push with just that one wheel on there. It was quite impressive. Now, my son's only 3 years old, 35 pounds. Unlike our schematics, I wasn't able to hang it from the back because, as you could see in this very picture, that I made the mistake and actually got the wrong wheelchair. So it was a combined effort of myself, Jason, and Andrew to try to figure out how we can get these to still work with everything that we had. The mounting brackets for the motors themselves, I procured those. They're 301 stainless steel, and it was very difficult to drill through. And some of the later pictures you'll see, I had to drill through and then hand file it in order to get everything to work. The initial plan was to weld everything together. Unfortunately, the brackets below are actually galvanized, and that don't work at all. At least it didn't work for me. So I ended up bolting everything together, and we still got everything to work within a reasonable time and function.
And what's cool about it is I think we kind of figured out what we need to do to even attach it to these type of wheelchairs. So.
Oh yeah, absolutely.
Definitely.
Now that we have even this, if we plan to move forward with it, we have a much better. Okay, I need to cut this. I need to measure it this. I need this kind of equipment in order to drill through certain things rather than hand filing. We can use different types of materials. It might be a little heavier, but I'll be able to weld it, in which case it'll cut down cost when it comes to bolting everything together. I still think it was a great concept. It was great in general. Now, again, joystick functions, that's going to be more Jason's thing there. Testing and going through everything, making sure it functioned before I got it. Next.
Yep. So this is just breaking down the two different systems. This was the electronic components here. So I had the wheels at the time, and as you can see, I put a little electrical tape on there so you can see them spinning. But as I'm moving the joystick, we got full forward movement, full reverse, full side to side. So one will turn more than the other, and then the for how much the joystick actually, how much you actually push it forward, it adjusts how much power is given to the motors. So it was really cool to kind of figure out all that code out and get it all working. But it's fully working like an RC car, so which is pretty cool. So it has the full capability of drive and turn, and with the speed adjustment, it's pretty cool.
This was my forge, or where I was assembling everything. Outside, New Mexico weather, 90 something degrees. It was a challenge, but as you can see, my son's even out there trying to help me on the welder. It's not plugged in, just so you're safe. Here, he's safe.
Safety first.
Yes. Next slide, please.
Can you see it, Dustin?
Yeah, there it is. Now I see it. Okay, sorry.
Took a while.
So yes, now you can actually see where the L bracket is, where I attempted to weld it in the left one, ended up having to bolt everything. That particular L bracket was just so rough. I had to end up using a diamond cutter on a grind wheel, basically, in order to get even that square to cut through. And on the right-hand side, fortunately, I still had a carbide drill bit. So I went through the center and then I used a hand file, filed it all the way. And I did that for like one or two of them until it dawned on me, why don't I chain drill it? In which case I drill it in a couple different areas, gets through the material a lot quicker, gets my job done a lot faster. And then I filed it down and made everything work. And it, like I said, turned out really great.
More lessons learned. Yep.
Yeah.
All right, and in conclusion, we believe Easy EV was a great success. We set out to do almost everything we planned on doing. The chair did move. It didn't quite move the capacity we'd like to move from the material that we use. Given our findings from some future work that we want to work on doing, is our biggest failure was on the friction wheel. We just want to update that wheel a little bit, maybe change it out of a 3D printed plastic. We might use injection molded, maybe a rubber wheel. But ultimately, this thing is pretty awesome. It's a fun project. We're happy with the results. And well, we want to revolutionize the wheelchair industry in the future. Any final words from you, Dustin and Jason?
Well, it was a great project. Yeah. I really appreciate the team. I think we did some great work here. It was a lot of fun.
It was a lot of fun, and I think we've accomplished our goal, making this thing under $500. In the future, even after the class, we've already discussed, we'll probably continue to meet up to see what we can do with this and try to distribute it to, at first, maybe some local veterans before we try to actually tackle the world, so to speak.